start with what is the problem statement, right? What is the problem? The problem statement simply says that implement a client server programming or implement a socket programming using C. And the statement is very simple, that just have a hello world program, right? A server is saying hello to a client, right? So first we'll see a hello server program. Now I hope you all remember the paradigm for the server, right? So what we have, see, just look at this includes, generally we just include this stdio.h, right? Now there are some different header files which is included in hello server and hello client.c. These are the socket.h, then in.h, like this. So why do we require these files? Because these files are specific for the socket programming, right? Then we have int main. We know that C program always start with int main, and then the important structure which is there for the C program is this sock addr in. I hope you all are able to see this sock addr in structure, right? What does this sock addr in do? Let's have a quick mhm. I think I'm not able to. No, I'm able to switch. Okay. Let's have the quick overview of what this sock addr do. Fine. Yes, sock addr in structure, right? I think you have seen that in our code also. What was that? Sock addr underscore in. Okay, so let's see what is this sock addr underscore in do. Correct? Okay. Why am I showing you? Because you must know what type of structures we are using and what are they all about, right? See, you can see here what they do. See, it is a, see, everybody is using this sock addr structure. Okay. Ah, yes. See, this is socket DDR in. What does it do? It has a socket family, port number, address, and then these are the paddings which are included. Correct. So this is generally kept as AF underscore INET. Then this is high to this is H2NS, right? And then structure in it. So we will see it one by one. So these are the basic structure for syscalls and functions, right? What does this structure do? This structure is, see, how do you feel the numbers in this structure and how do you feel the data, right? So this particular structure is used for, this particular structure is used for the socket programming. Now we'll go back to our own code. So what we are doing, we are creating two members for these structures or two variables for this structure, the server addr and client addr. Then we have a buffer size and then crc buffer size, and then we have this lesson fd and connectivity. See, you can see it is as an integer. Now first what we have to do is we have to create a socket, right? Socket is the api. Now how to search for these apis, right? How do we come to know about what does this api? So you can do man socket. So let's see what does it has displayed. It has displayed a manual page which says about a given api. So what does this says? It says socket api creates an endpoint for communication. What does it require? It requires sys slash types.h and sys slash socket.h. Have we included all these headers? Yes, we have already included these two headers. Correct? We have already included these two headers. Right. So it creates an endpoints. Now what are the inputs? Inputs are domain, type, and protocol. I hope you are able to see this manual page. Input for the socket is domain, type, and protocol. Correct. Now what is this domain? This domain says about what is for particular domain we will be using. for the current socket program. Now we have given the input as AF underscore inet. We have given the input as AF underscore inet. What does it mean? It is IPv4 internet protocols, right? We are using IPv4. That's the reason we have given AF underscore inet. Correct. Then the second argument is a type of a socket. Right. Now, what are the different types of the sockets available in Linux? So there are stream socket, datagram sockets, and the sequent packets. So these then the raw socket, RDM packet, and sock underscore packet. So these are the different types of the sockets which are available in Linux. So here we are using a stream packet, right? A sock underscore stream socket. Now, what is this sock underscore stream socket? It provides sequenced, reliable, two-way connection-based byte streams. So please remember, this is a reliable connection and it is a two-way and connection-oriented communication. This sock underscore stream is going to give us a connection oriented communication. Similarly, at this moment, I want to explain you about sock underscore dgram also. Correct. What does it do? It supports datagrams. Datagrams is what? UDP sockets. Correct. So UDP sockets are connectionless, unreliable messages. Understood all of you? So this sock underscore stream gives a TCP socket and sock underscore dgram gives a UDP socket. I hope this is clear with everyone that sock underscore stream gives a TCP socket and sock underscore dgram provides a UDP socket. Then the third parameter was a protocol type, right? So that we are making it as a 0, which so this, what does this protocol says? It specifies a particular protocol to be used with the socket, right? Normally only a single protocol exists to support a particular socket type within a given protocol family, in which case protocol can be specified as 0. So currently we are specifying as 0 because we are supporting here a TCP protocol. So we are giving this as a 0. So here we have created a socket. Fine. So what does this returns? It returns a descriptor. You can see here it returns a descriptor, right? What do you mean by descriptor in a programming? A descriptor is a handle to handle that particular object or to handle that particular activity. Fine. Now here we have created a socket. So to handle activity of a socket or to handle the things which are related to socket, we require a handle, right? That is also called as a descriptor. So this particular descriptor is returned by a socket function and that we are storing in a listen FD. If we get any error, right? Now again one more point. In C programming, if any APIs fails, it returns -1. You can see here it returns -1. If any APIs fail in a C programming, it returns a -1. So this once you get a return value as a -1, what we will be saying? We will say that a socket creation error. That means that a socket creation has failed down, right? And P error is is a function in a C which prints your error, right? So this is going to say that there is a failure for this particular call. So whenever any API returns -1, it means that there is a failure in a execution of that API. Otherwise the socket is created successfully, right? So listen FT now is going to be a handle for a socket. Correct? The socket to create hua, right? In that day, in a lecture we have seen that first we are supposed to create a socket, right? Then what is our task? Our task is to do a bind, right? I hope you all remember bind. I hope you all remember the bind function. Yes. So here what we are doing is, see, we have created a variable for the sock address. So first we are making it as a 0. So B0 function is used for making it as a 0. So we are filling that complete structure with 0 so that there will not be any junk value or a garbage value in a structure. And then we are appending our required values in that particular structure. So we have seen that sin underscore family we have put as AF and INET. Then INET address. See, sin addr dot s dot underscore addr is equal to inet underscore addr, which is 127.0.0.1, which is your local host. So we are giving this local host to a address, right? And the port number is we have given here a port number as 5000. Now we have used a function as H2NS, that is host to network. What does this H2NS do? It converts the unsigned short integer host from host byte order to the network byte order. Understood? Because for a network communication we require a different ordering, and which is done with this H2NS function, that is host to network socket function. Correct? So you are converting from a host byte to a network byte, right? And then now what you have done, you have filled this sock addr underscore in structure with the required data, राइट क्या किया है हमने, एक स्ट्रक्चर है, उस स्ट्रक्चर का एक वेरिएबल क्रिएट किया है और उसमें जो रिक्वायर्ड डेटा है, रिक्वायर्ड डेटा कौन सा है, जैसे फैमिली है, देन एड्रेस वी हैव एंड पोर्ट नंबर, दिस ऑल रिक्वायर्ड डेटा इज फील्ड इन अ that particular variable, correct? And now we are sending this variable, see look here, we are sending the variable with a bind function, right? So what bind does do, the bind is going to bind your socket, right? A bind is going to bind your socket. So what does it do? So for inputs for the bind, see, you can go back to your man page, and here you can do man bind. Correct. Now what does it do? It binds a socket. And what are the inputs for this? Inputs are sock FD, right? A socket FD which we have received after the creation of the socket, a constant structure sock ADDR ka variable and uska length. Right? When a socket is created with a socket, it exists in a namespace but has no address assigned to it. Are you getting this? So bind assigns the address specified by the ADDR to the socket referred to by the file descriptor sock FD. Understood all of you, what does this bind do? So this bind is going to bind your socket name to actual address space. Fine. So here I am binding it. Correct. Again, suppose if this bind address call returns -1, it means that there is an error. So we will be displaying as bind error. Correct. Now after bind, what was the API which we have seen, or what was the primitive which we have seen in the Barclays API, Barclays socket programming? After bind, we are supposed to do listen. I hope you all remember what I explained about the listen yesterday. So what does the listen do? A listen says that to how many client a server can be connected, right? To how many client my server can be serving at a time, right? Now here I gave a input parameter as a listen into bracket listen fd comma 4. Correct? Let me open the man page of listen as well. So let's see this man page, the what we are doing. Okay, so listens for the connection on a socket. So listen marks the socket referred to by sock FD as a passive socket. That is, as a socket that will use to accept incoming connection request using accept. Understood all of you? So this listen is going to listen to the incoming request with of connect. तो यहाँ पे when I say a listen comma fd, listen into bracket fd comma 4, it means that my server can entertain to the 4 clients, maximum 4 clients at a time. Fine. So here I am up to the listen, correct? And then what I told you, as I already told you, that listen is going to be a blocking call, right? A listen is going to be a blocking call. So what does it mean? See, if you want to test whether how it is a blocking call, I can print here. See, printf listening. Correct? I say that it is listening. Fine. So Just check which print will be printed. Listening before listening. Fine. And then this was after listen. After listen, right? As I already said that it is a blocking call. So let's test this while executing a program. And now after the listen, what I have to do? I will be accepting a request from the client. Now go back to the client program, right? Let me switch back to the client program. Here I'm at the client side. Again, at the client also, I have to declare a variable for socket ddr underscore in, and then I will be creating a socket. Fine, a socket with s underscore af underscore inet and sockstem, because here we are creating a connection oriented socket, that is a TCP socket. Understood all of you? And then same procedure I'm following again. Here I'm making my this particular variable as a 0 with using b0, then filling it or populating that particular structure with a scene family, then address, and then the port number. I'm supposed to connect on the same port where my server is running, right? So that's the reason I'm using the same port over here. And the next part is, see, at a client side, I'm just supposed to create a socket and then call a function connect. Right. So here I'm calling a function. Now look it very carefully. What I'm doing here, I have used this sock FD, which is a handle for the socket, and then the client information. See, client address I'm sending over here and the size of a client address. Right. So once I'm here at a connect, once I say a connect at the server side, a server is going to accept it over here. Here there is an indefinite for loop. I hope you can see this. This is an indefinite for loop, and the server is going to accept this particular request. So this particular request has been accepted for a socket. Listen FD, ये हमारा socket है ना, right? So this particular request is accepted with respect to a given socket which is created at a server end, and the details of the client is received as in a client ADDR. क्योंकि क्लाइंट ने भेजे ना अपने डिटेल्स ये सेकंड पैरामीटर में, वही डिटेल्स हमारे यहाँ पे एक्सेप्ट हुए, क्लाइंट एडीडीआर में सेव कर दिए हमने, राइट? सो इट हैज एक्सेप्टेड द रिक्वेस्ट फ्रॉम द client, correct? And then what I am supposed to do, this is a simple hello world program, right? I hope you remember the problem statement. So this is a simple hello world program. So I will be copying a hello world string in a for a communication on with the right API. Correct. So before that, I took one buffer. In that buffer, I have copied a required string that is a hello client server. So I copied it in a buffer, and then I have returned this buffer. This particular buffer, I transmitted this data of the buffer to the connection. Right, so I have returned the data, or I have sent the data, whatever required data, to the client with the help of the connection FD. Right, what will happen at this client end? A client end is going to read the data. Right, so here at the client side, I am reading the data. I hope you all are able to see this read. Correct. So at the client side, I am doing a read on a given socket, right, with a buffer receive line. See, this is my buffer receive line. So here in this buffer, I will be getting a data which has been sent by a server. Correct. So I am reading it one by one. Fine. I'm reading the at the client end by one. So that particular part I'm writing, and then I am putting it on the standard out. What is this std out? STD out is a standard output device. We have the STD in, we have the STD out. You must have seen the file handling in OOPS, right? I think it must have taught by Millie ma'am in your second year. So over there, a file descriptor 0 is used as a standard in. right? A file descriptor 1 is used as std out and file descriptor 2 is used at std error. The same concept is available in C programming also. So here I am putting a file put, right? F puts लिखा है ना तो file का right है ये, file puts function. So I have put the data on a file descriptor which is known with std out. This is the standard variable or reserved variable. That's the reason I can use it std out. Until what I will be putting, till end of a file, I will be putting the data on standard out, right? And thus I will be getting my data. If this fails, then I will be writing f puts error. And if the read itself fails, then I will be writing a fp error, a read fail. So at a server end, come back to the server end now. So at a server end, once I write the data to the client side, I do not need a connection object anymore because my task is just to write a hello world or just to write a hello to a client. So my this particular server is no more required, and that's the reason I have said close connection FD. Right, so I have closed my connection. So I have closed my connection, correct? I closed my connection and I can accept a new client request later on. So this is how my hello world looks. Hello server, hello client programs. Now going back to the terminal. Fine. I hope you all know how to use the terminal. If you doesn't know, I will show you. See, this is my terminal. I have copied my code into the folder called CN, some name to this, and then I can do ls is going to display the content of a given directory. Oh, I'm so sorry. So I need this hello world program. Hello program, correct? Ls again. So what things we have? I have this hello client.c and hello server.t. Remaining I will remove so that there is no confusion to you. Fine. So I have this client ls. You can see ls over here. So there is a tilde file that also I will remove. Mhm. Just a second. rm okay server.c and till, correct? So it has removed my files. So currently I'm having just two files over here. So ls minus l, so it shows the listing hello client.c, hello server.c. So at one terminal I will be compiling and executing the client program, and at another terminal I will be compiling and executing the server program. So gcc minus o, please remember here, if you do just simple gcc, if you just do the gcc hello client, see you can see hello client dot c, right? So what will happen, your output file will be created, right? But that is with a dot out. Now at the same folder you have server.c also, right? So if I do gcc server, sorry, hello server.c, again I will be having same a dot out. So my previous client का a dot out जो था और client का, or you can say previous uh, executable object of the client program will be overwritten server program, right? Which I don't want, and that's the reason this programs, whenever you are doing a client server programming, either you use the different folders, or in the same folder if you want to create two different executables, you are supposed to use a minus o option. So minus o option is going to give a name to your output file. So here I want to give a name as a client to a client program. So minus o client, that is my name to the executable, and hello client.c. So my hello client.c will be compiled by GCC and it is going to create a output file as a client, right? So here you can see now my client file is created. Are you able to see this client? Okay, it is still coming, I think. So you are able to see the client file now, right? I think you are able to see the client file. All of you able to see the client file? So my client file has been created. Now in a similar manner, I will be compiling a server file also. So GCC minus O server. I want to give a name to the output file as a server. And what is the name of the C file? Hello server dot C. Correct. So if you do again ls minus L, you will be able to see the two output files. So one is a client and another is a server. Right. So I need a and one more terminal for this to execute one terminal for executing a server program and another pro terminal is to execute a client program, right? So I will be executing this hello world. Fine. So ls minus L, I am able to see here. So here say I will be executing this server. So dot slash server. So socket created successfully. I get a display as at a server end, and then I go to the client side and I do a client program. So what I do get here, socket created successfully, connected successfully, hello client server, and then my client is exited. My task over here for the client is just to accept hello from a server. I hope you all remember that we have returned this hello. Where is my server code? Yes. Hello client server. Who has written this hello client server? A server program has written it, and it is written on a return to a client side. It is sent to a client over the network. This hello client server is sent to the client over a network. So in output also we can see this socket, this here I have executed a client program. I hope you all are able to see here. I have executed a client program and client have received whatever has been transferred by a server. So hello client hyphen server has been received at a client end using a read call. With the help of a write call, a server has returned the data, and with help of a read call, a client has received the data. Correct. I hope this code is okay with all of you. I hope you have understood the client server programming in C.